And you see what we have here. We have one cluster called Watchdog dev.ref and one called Robot Drive dev.ref. If we go back to this global variable, if we click on it in the center so that we get our finger tool, we can pull that down and select from any of the clusters which have been created on that global variable. What we want to do is we want to add a new element to that global, and the element we want to add is the servo ref. There's a couple different ways to do that. The simplest, I think, is to open up the servo open.vi, which we see here has our PWM device ref. We're just going to copy that guy and then close it, making sure that we didn't make any modifications to that VI. So now we're going to open up that global again. This time we're going to use a different method to open it. We're going to go to the Project Explorer and see that we have our basic Robot Global listed here. So we double-click to open that global, and we're going to just do a paste. So now we've added our PWM device ref. The next thing I'm going to do is I'm going to change the name of this, because PWM device ref is not a very useful name. We're going to call it our pan servo reference. We're going to pretend that it's part of a pan tilt system, which is allowing us to move our camera around. We're going to save and close the global. What we need to do now, I'm going to just move this guy over to make a little bit more room. What we need to do now is bring up a copy of that global. We can do that just like we've been making copies of things for a while now by using the Control key and dragging an existing global. Another way we can do it is if we go to the project window, we can actually drag the global from the project window onto the block diagram. And then all we need to do is access the finger tool by clicking in the center to choose the right reference. And in this case we want our pan servo reference. And remember, we want to write to it. Global variables are interesting because they can be written to or they can be read from. And the way that you change that mode is by right-clicking on it and choosing Change to Read. So if I change this guy now to be changed to read, I get a broken wire, because I'm trying to write to an output, which of course is illegal. If I right-click again, it toggles back to change to write. So in this way, I'm writing to that global reference. Remember, what the whole point of this was is so that we can make modifications to our autonomous mode code to access this servo. So let's return to that VI now. So now that we're here, let's go back to the project window again and drag a copy of that global over. So again, it's been created, it's been pre-selected to be the robot drive, so we want to change that again by clicking on it and choosing pan servo reference. And also, notice how the icon looks a little different than this one, because by default it's created in write mode. In this case, we've already created the servo reference, we've already written to it, we want to read. So we're going to right-click and choose Change to Read. So we'll make a little bit more room here. And recall what the task was. What we wanted to do was have it go from one position to another position every 5 seconds. So in this case, let's create a while loop. Because remember, a while loop allows us to run until a condition is true. We're going to set a constant with value false because we want this to run forever. Remember that the autonomous VI is automatically started and stopped by the framework. So we can write code here which, if we want to run for the entire duration of autonomous mode, we can basically create while loops that run forever. So now what we're going to do is we're going to write to our servo. Go to our robotics library, actuators, servo, and set angle. So the two inputs we need here are to take our device ref, which we've gotten from the global that we just created, and to set the angle. We're going to create a constant of 0. Now we're going to create a delay. So if we take a close look at the above autonomous code, the stuff that's been provided, we've got this function block here, and if we activate the context help, it's called delay and feed. We could do a very simple delay by using one of the LabVIEW timing delay functions, wait or wait until next millisecond multiple. The problem with that is that we have something called the Watchdog timer built into the robot. The purpose of the Watchdog timer is to shut down your outputs, to basically go into a safe mode whenever the code locks up. And the way Watchdog timers work is you must feed a Watchdog periodically. If the Watchdog timer goes to 0 before it's been reset or fed, then it goes into the alarm state and the system will shut down. So we cannot put a simple LabVIEW-based delay in here because during that delay it will not be feeding the Watchdog. So that's why this function has been created. And it's available in our robotics library under Utilities, Watchdog, Delay, and Feed. So it's a convenient function that allows us to set a delay of a certain amount of time. In this case, we wanted to wait 5 seconds. Change that constant. And then we want to, at the end of that 5 seconds, do another servo call to set the angle. And in this case, we'll do an angle of 170. We're going to connect up the device ref from the output of the first call to the input of the second call. So take a second and ask yourself if this code is going to work. Well, there's a couple things missing. First, we wanted to delay not just before we change angles, but also after. So there needs to be a second 5-second delay. But also, remember how execution works in LabVIEW. Functions don't execute until data is available at all of their inputs. And if there's no data dependency between functions, they will run at the same time. So a very common mistake using LabVIEW is to write code like this and assume that it's going to do what you wanted. In reality, what's going to happen here is the servo set angle 0, the first Watchdog 5-second feed, and the second Watchdog 5-second delay and feed will all start firing at exactly the same time. Immediately after the first servo set angle goes, the second servo set angle will go. Why does this one wait for the first one to finish? Well, in this case, there's a wire connecting them. In other words, there is a data dependency between these two. Well, you may see the solution because it's given to us above. There's an error signal here. The error output can be used in a very convenient way to chain things together to force them to happen in a certain order. So just like this wire caused the second servo set angle to happen after the first one, we can do this. If we chain the errors up, then it will ensure that they happen in a very fixed and determined order. In other words, the servo will be set to 0, then it will wait 5 seconds. Then the servo will be set to 170, and then it will wait 5 seconds again. And then the whole loop will repeat. So the only thing left to do, and we can see that we have a broken VI, if we try and run it, it's going to tell us what the errors are. The only thing left to do is to actually connect up the Watchdog device ref to those other two delay and feeds. So let's take a branch off this wire. And now we've got a VI that's ready to run. As long as this Boolean's been set to true, our autonomous mode will be active. I'd like to recommend that if you don't have your robot up on blocks, and if you're not sure whether it's safe to make it move, that you delete this portion of the autonomous code. So maybe I will go ahead and do that right now. That way I can be sure that the only thing that's going to move in my autonomous mode is the servo that I've created. So then all you need to do is save and close this VI, and then run the robot main to deploy it. It may ask you to save changes. Once you do so, it will deploy. And then once it's running, you can probe to look at your angle in teleop mode, which will also be a nice way to tell you once the robot has actually started and begun executing. Okay, you want to make sure to enable your robot. And then by changing your gyro position, you should be able to actuate the servo position. Now that's in teleop mode. If we then switch back to autonomous mode,